Okay, in this lecture we're going to talk about equations that are in quadratic form, even though they are initially not a quadratic, just in one variable. And this comes from a form that says this. Let's suppose I have an au squared plus bu plus c is equal to 0, where u is some algebraic expression. So in other words, it's some something in x here. U is some algebraic expression in some other variable. Right, now of course a is not equal to 0 here, or we wouldn't have a quadratic form at all, but you can see that it's in quadratic form. It's just that we have an expression here rather than just a single variable x. Right, so let's look at how we actually go about doing this by looking at an example of one that is in quadratic form and how we go about solving it. So let's do here, let's solve each equation. Right, part A. Let's suppose I have x take 3 to the 2/3 minus 6 by x take 3 to the well, let's make this a half, shall we? Alright, x take 3 to the power of a half, and we have 6 by x take 3, let's suppose this is to the quarter, and we have a plus 8 equals 0. Now, first inspection, this doesn't really look like a quadratic, okay? However, if I was to take u is equal to x take 3 to the quarter, what would u square be? Well, it would be x take 3 to the quarter, squared, which of course would be a quarter times 2 is a half, so it would be x take 3 to the half, which is exactly this term here. So what I could do is say, well, if I use x take 3 to the half, I'd have a u squared here, minus 6 times, I've got x take 3 to the quarter, well that would have been u, plus 8 equals 0, and now we have a quadratic form. Now the way we solve a quadratic like this is we look for factors of 8 which add up to negative 6, and that'll be negative 2 and negative 4. Okay, and of course we factor this now, so this implies then that u minus 2 equals 0, or u is equal to 2, or u minus 4 equals 0, or u equals 4. However, this u is really sort of like a dummy variable. It's just allowing us to get at this quadratic. So this is not our answer. Our answer must be in terms of x. So this tells me that x take 3 to the quarter is equal to 2, or x take 3 to the quarter is equal to 4. Now, how do we get rid of a fourth power? Well, that's a fourth root, so we take it to the power of 4. So I'd end up with this, like so, which means here we have, of course, 2 to the power of 4 is 16, which implies that x is equal to 19. Alright, and here, of course, this is going to imply that x take 3 is equal to 4 by 4 is 16, by 4 by 4 is 256. So this means that x is going to be equal to 259. And so our solution then will be 19 and 259 is what my x values are. Alright, another type could be like this. So let's suppose we have 15x to the negative 2 minus 4x to the negative 1 is equal to 3. Now here, of course, again, it doesn't look anything like a quadratic, but what if I was to use u is equal to x to the negative 1? Then u squared would be equal to x to the negative 1 squared, which of course is x to the negative 2. So if I now have this, I have 15, instead of x to the negative 2, I'd have u squared minus 4 by u. Let's bring the 3 across and I have 0. And so now we do have a quadratic, and we're looking for factors of 15 by negative 3 is negative 45, which add up to negative 4. So let's have a look at that. Negative 45 is what we're looking for, factors. 15 by negative 3, which add to negative 4. Now, to do that, of course, I'd say 15 and 3. No. So what other things are factors? So let's have a look. So let's try 15 u squared. Now we need a negative 4 here, so we need, say, something like a 3 and something else. So 3 and 15. So let's have a look at a 3. So that would be a 5. So we need a 5. Let's have a look. So not always easy to look at this. So negative 3 and 15, that doesn't work. Negative 2 doesn't work. So what about 5s? 5 and 9. Ooh, there we go. 5 and 9. So if we have a negative 9 and a positive 5, that will give it to us. So here we go. So this will be a plus 5, so we're on the right track. Minus 9, oh, this will be u. Minus 9u minus 3 equals 0. So if we take out a 5u now, we'll end up with a 3u plus 1. And if I take out a negative 3, I will get a 3u plus 1. Okay, so here we'll have a 3u plus 1 by a 5u take 3 equals 0, which implies here that 3u plus 1 equals 0, or u is equal to negative a third, and or we have 5u take 3 equals 0, or u is equal to 3/5. Alright, so either way we haven't finished here, because remember u was equal to x to the negative 1. So what I have is x to the negative 1 is equal to negative 1/3, which implies that 1 on x, that's what x to the negative 1 is, equals negative 1/3, which implies that x is equal to negative 3. Turn them both upside down. Or here we have x to the negative 1 is equal to 3/5, which implies, of course, that 1 on x is equal to 3/5, or x is equal to 5 on 3. And so our solution is going to be negative 3 and 5/3. Okay. Right, so that's how we do that one. So notice in this case, these cases here, we're looking for in these types of forms, so that we're looking for a u value that allows us to get it into this particular kind of form here.